This is a demonstration of Simbeor Commander, the IDEA industry first signal integrity tool powered by LLM. So in this project, I use CMP28 from Wild River Technologies. There is a new version, CMP70, but this is old one with a lot of kind of data about it. So I will use this one today. It has simple 8-layer stackup here, and with some defined materials imported from BRD file or from ODB file, ++ files. So same thing. So what I want to do is to compare it with PDF document describing the stackup by manufacturer, how it is going to be, it was going to be manufactured. And so that's difficult to read for human, but not so difficult for LLM. So to do this comparison, I use Simbeor Commander, powered by Qwen Plus in this case, and the first prompt is going to be import, and I'll pick up the file and send this command. So I ask Simbeor Commander to import stackup into a new project and compare it with stackup in project 1, an existing project that was imported from BRD in this case. So I can see that the project is imported. So manually, just visually comparing those stackups would be difficult. So those are materials. This is stackup data. Again, same 8-layer stackup. And here is comparison of data. So it gives some details about key differences. So are those differences important for signal integrity? Let's just do a brief check and see how it impacts signal propagation, impedance, and or trace width for a given impedance, and losses. I ask Simbeor Commander to build models for 50 ohm Coplanar traces, 10 mil clearance in each signal layer, in the original and imported stackup. Plot losses on the same plot for comparison, and compare losses at Nyquist frequency. So there are a lot of steps here to orchestrate. So let's see how it manages to do this. So Qwen start building, found the width for each layer here for Coplanar traces. Used by default Simbeor SFS field solver, and those are 50 ohm transmission lines indeed. So it builds it for in each stackup. So they're slightly different. Okay, now we are using Simbeor side by side, my helper Simbeor Commander and myself. And looking at the losses, computed up to 15 GHz with taking into account all the effects of those materials here. In neither stackup, I see no roughness specified for the materials. In a moment, it will give me a summary of findings for all those losses. Let's see. And the next step will be to compare it with identified material, stackup material models, which includes the conductor roughness. So Simbeor Commander gave me trace width. You can see what difference in the stackup produce in if you want to find 50 ohm Coplanar transmission line in BRD stackup and in the stackup from manufacturer, and actual impedance, attenuation, delay. So, and gives me some. Finally, I have the same stackup described in Simbeor, actually not in JSON format, with identified materials, material properties, including conductor roughness. Let's see how that one is different from the two previous ones. Let's see. So, Simbeor Commander was LLM found width for 50 ohm transmission lines, in this case for new stackup. New stackup includes conductor roughness models and includes identified dielectric models. And so in a moment, it plotted it on a new graph here for two top layers. It's finally it figured out that the stackups are symmetrical. And okay, and gave me a summary of those found. So this I'm using the version available at our website. So download it, get a license if you don't have license, plug in your favorite LLM, and do the signal integrity with AI.